The diagram shows part of a curve y equals blah blah. The curve cuts the y-axis at A and the line x is equals to 5 at B. Show that the equation of line AB is equals to this. Okay, for that we need coordinates of A and B. So we at A, we know that x is 0. And let's substitute y here. Let's substitute x is equals to 0 in this equation and get y as well. So at A, x is 0. And when we substitute 0 here, we get y is equals to 1. So y is 1. So this value of y is 1. And similarly at B, we know that x is 5. Let's substitute 5 here in place of x and get the value of y. Okay, so denominator would be 3 times 5 plus 1, and its power is 1/4, which is the fourth root, which gives 2. So y is coming out to be 1/2. So this y at B is half. Okay. Now we have to find, gradient of this line and then its y-intercept. Y-intercept is already 1. So we will not be wasting time finding C. C is equals to 1, we already know. From here, C is where your line cuts the y-axis, and from the graph, we can see that that's 1. Okay, so all that's left to find is the gradient. So M is equals to y2 minus y1 over x2 minus x1. That gives 0.5 upon 5, that is 1/10. Sorry, negative 0.5 upon 5, which is negative 1/10. So the equation of the line AB is y equals mx plus c. Okay, that is shown. Part 2 says find the volume obtained when the shaded region is rotated 360 degree about the x-axis. Okay. So since this is the shaded region, so what we'll do, we'll first revolve this around the x-axis. So we'll get a shape like a frustum. We'll find this volume, and then we're going to revolve this around the x-axis. And then we're going to, so this will become a shape like this. And then we will subtract the results and get the volume of revolution of the shaded region. Okay, so I'm going to use the integration formula for volume of revolution. Okay, let's find volume of this line first. Okay, so the formula of volume of revolution about x-axis is pi, lower limit of x, upper limit of x, function squared dx. Okay, so it's going to be pi. The lower limit of x is 0. The upper limit of x is 5. The function is the straight line, which is minus 1/10x plus 1 squared. And then we're going to subtract pi, same limit 0 to 5. The other curve is this. So function, I'm writing 3x plus 1 power minus 1/4. I've taken it into the numerator. And now I'm going to square this and solve it. Okay, now we will be squaring these curves and then integrating them. So we have pi 0 to 5. On this, we'll apply a square minus 2ab plus b square. I'm going to write 1 minus 1/10x. 1 minus 1/10x. Okay, so it's a square minus 2ab, so 2/10x, plus b square, so 1/100x squared. Then we have dx. In fact, 2/10 I'm writing as 1/5. And then a minus sign. Integrate this. This would become 3x plus 1. And when we square it, it's minus 1/4 times 2. That is going to be minus half. In fact, now I'm thinking there wasn't really a need to expand this. We could have used integration of composite functions here. like we'll use here. But anyway, now since I've expanded it, I'm just going to go with it. But it was not a good idea expanding it. It's going to take me more time to integrate it now. Okay. So yeah, I could still go back. Let's go back and not expand it. So I'm getting 1 minus 1 over 10x squared still. I did not expanded it. I did not expand it. Okay, anyway, back to this. So now we integrate these curves. So this is 5, not pi. Okay, so let's integrate this. So we have fx inside the power that needs to be integrated. So remember the rule for that. It is fx n plus 1 upon n plus 1 times f prime x. That is the derivative of fx gets multiplied in the denominator. So we have 1 minus 1 upon 10x. Power becomes 3. So we have 3 here. And then the derivative of this would be minus 1 over 10. Okay. And there's a pi outside. And we integrate this from 5 to 0. Then there's a negative sign, another pi. And this would be 3x plus 1. Add 1 to minus half, that's going to be half. We also get n plus 1, which is half in the denominator. And the derivative of 3x plus 1 is 3. And now we substitute the limits, 5 and 0. Okay. Now let's substitute the values. For the first one, I'm writing pi outside. Let's substitute 5. In fact, I'm also going to bring out the coefficients. This is minus 3 upon 10 in the denominator, which can be written as 10 upon minus 3. The 10 goes up and the 3 is down, and also the negative is usually written with the numerator. So minus 10 over 3. I'm going to bring that out to make the math easier inside the bracket. You can bring out the coefficients. Okay. And now we have just 1 minus 1 upon 10x power cubed. Okay, let me bring this out here as well. Minus 10 over 3 is out. Now let's substitute 5 first. So we have 1 brackets 1 minus 1 by 10 times 5 power cube. That's giving me 1 over 8. Minus, substitute 0, we get 1 cube, which is 1. So subtract 1 from 1 over 8. Now multiply that with negative 10 by 3 pi. That is giving me 35 over 12 pi. This becomes 35 by 12 pi. Okay, let's check this one out. So in the denominator, we have 3 over 2, which becomes 2 over 3 comes outside. So that's out now. Okay, we have a 2 over 3 here. Okay, now let's substitute 5 and then 0. Okay. Substituting 5 gives us 3 times 5 plus 1 is 16. 16 power half is 4, so we get a 4. And then minus, when we substitute 0, we get 1 power half, which is 1. So this becomes just 3. And when we multiply it with negative 2 pi by 3, it just becomes negative 2 pi. So we have 35 upon 12 pi minus 2 pi, which is coming out to be 11 by 12 pi.